Okay, I'm going to make a little video for the Unit 5 celebration. So here we go. First thing, we're going to figure out all this information. So the negative sign in front, that will vertically reflect it. So vertically reflected. And then the 4 on the outside like that, that's vertically stretched because it's bigger than 1. Then we got the negative 10 under the radical, so that will go moving it right 10 units. Then we have the plus 5, so that will move it up. So that will go up 5 units. Now the domain and range, the domain will be shifted right 10 units. So instead of it being x is greater than or equal to 0, it's going to be x is greater than or equal to 10. And then the range is shifted up 5 units, so it will start at 5, but it's been reflected, so instead of going up, it's going down, so it'll be y is less than or equal to 5. Alright, over to this side, looks like we have a horizontal reflection. That's the negative sign under there. So horizontal reflection. And then we have the 5 is a horizontal, and remember it's the opposite, so this is a horizontal compression. It's a horizontal compression by a factor of 5. Then we have the minus 11, so that's down, and that's down 11 units. Now the domain, because it's been horizontally reflected, it's going to be x is less than or equal to 0. It's normally x is greater than or equal to 0, but now it's x is less than or equal to 0. The range is starting down there at negative 11, and then it's going up. It hasn't been reflected or anything, so it's going to be y is greater than or equal to negative 11. All right, I think we got everything on there. Okay, similar question, domain and range. So domain looks like it's been shifted to the right 1 unit. So that means the domain is going to be x is greater than or equal to 1. The range is starting there at negative 3 because it's been shifted down 3, but then it's been reflected, so it's going to be y is less than or equal to negative 3. So as far as the graph goes, this is the parent graph that's shown here. So we're going to be going over to the right 1 unit and down 3, so we're starting here. We would normally go up like this, but we're not doing that because it's been reflected, so we're going to go down like this. Okay. Next one. Okay, we have a domain here. The domain looks like it's reflected horizontally because of that negative sign. So we're going to say x is less than or equal to 0 instead of x is greater than or equal to 0. And then the range, it's been shifted up 4 units. So we're going to say y such that y is greater than or equal to 4. so we have the parent graph shown there. So we're going to go from there, we'll go up 4 units, and it would have normally kind of been like this, but it's not, it's reflected horizontally, so, whoops, it's more like that. Okay. Remember, you can just pop these into the calculator to get a good graph too. All right, so let's write some equations real quick here. So we got y equals, it's been vertically reflected, so it's going to have a negative sign out in front. It's been vertically stretched, so it's going to have a 5. It's been shifted to the right, so that would be under the radical there, so that would be minus 15. And then it's been shifted down, so that would be minus 12 at the end. This one has a domain that's less than or equal to 0, so that means it's been horizontally reflected. So it's going to have a little negative x there. And then the range has a 3 here, so that means it's got to have a plus 3. And then it says it's less than or equal to 3, so that means it is not going up, so it's actually going down. So we got to put a little negative sign in front to show that it's been vertically reflected. Next one. We got y equals, the domain is x is greater than or equal to negative 12, so it's been shifted to the left 12 units, so that's x plus 12. And then the range has a little 4 there, so we'll put plus 4. And it is greater than or equal to 4, so it doesn't have to have any negative signs to, make it reflect. All right, we got properties of exponents to work out here. So the ones we want to combine are the x's right above each other. We're going to subtract the powers, and then same with the y's. So let's just work on a common denominator. So that's 2/5 and 4/3. So I'm going to shoot for 15 for the x's for the denominator. So for the x here on 2/5, I'm going to have to multiply by 3. So I'll put a little 3 in front of each of these. So that'll make this a 6. Then for this one, I'm going to have to multiply it by a 5, top and bottom. So that's going to be 20. Okay, that one will be ready to go. Then the y's, this is like 2 over 1. Oops, not 2 over 2, 2 over 1. Okay, so we need to have the same denominator. So the only denominator we have is, well, a 3 and a 1. So let's go for a 3 on the bottom. So this one's going to be 8/3. The bottom one is going to be, we're going to have to multiply this bottom one maybe by 3 over 3. So that's going to be 6/3. So this will be 6/3. If you do 6 divided by 3, that's 2, so that works. All right, so now let's subtract the powers. That's the property here, when they're right above each other. So it's going to be x, and 6 minus 20, that's minus 14 over 15. And then the y's, that would be 8 minus 6, so that's 2/3. And then we want to get rid of negative exponents, so we'll flip this guy. He'll be more happy on the bottom. Make him a positive exponent. And then we'll leave that y to the 2/3 on top. Okay, this is a power to a power, so we're just multiplying the powers, just literally straight across. So this is x, 3 times 2, that's 6. 7 times 2, that's 14. So that would be okay answer, but we can just reduce it a little bit. So they have some 2's in common, so that would be 3/7. What some people do with the original problem is they would just cancel out the 2's and then just multiply straight across and get 3/7. Either way. All right, this one we're just gonna, keep the base, which is the x, and just add the exponents. So we need a nice common denominator. So let's go for a 6 on the bottom for both of them. This one's already a 6. Let's make the other one a 6. So to turn a 3 into a 6, you got to multiply by 2. So we'll do that. we'll multiply the little top and bottom here by 2. That's going to make 2 times 2, which would be 4. So now they'd have a common denominator. So we keep the x, we add the numerators, keep that same denominator. So 9 over 6 is not a terrible answer, but we can reduce that. So we can say x raised to the 3 over 2. Or x raised to the 3 halves, we say. All right, so these ones always look the ugliest. They're not too bad if you just take them step by step. So everybody gets the 1/2 on the, as a power. So that's 9 to the 1/2. It's x to the 1/2. It's x, and then if it already has a power, then you multiply those numbers. So that would be negative 1/2 now. And then y, and that's 4 times a half, so that's 2. All right, so now what we're going to do, a couple things. 9 to the 1/2 is really just the square root of 9. See, the 2 goes there, the 1 goes there. So that means it's just going to be a 3 on the top. The y squared is already happy where it is. The x to the negative 1/2 actually comes up to the top, joins his friend there. So then what you'd have on the top is you'd have x to the 1/2 and then times x to the 1/2, and then you'd be able to add those powers together. 1/2 plus 1/2 is, 1 or 2 over 2. And so we're going to say that we have just x to the first power, or just x is even better. So that's our final answer. All right, so we got a little combining to do on the bottom first. So let's see, we want to get a common denominator. Right now it's 2 over 1. So let's go for 3's on the bottom. So let's leave the top alone. So we have x, let's make 2, let's turn it into 3's, let's make it 6/3. And then this is x to the 1/3 still. Let's carry this x to the 1/4 over here. And then now we can add these together. So that's going to be x to the 7/3. And now we need to work on trying to get a common denominator. So let's go for, there's a 4 and a 3 on the bottom, so let's go for 12. That means we're going to multiply this one by 3, top and bottom. So that would make it 3/12. And then this one on the bottom, we're going to go, let's make it x to the something 12, so let's figure it out. So we're going to have to multiply by 4, top and bottom. So that would make this 28 over 12. Now we can use the property when they're right above each other. That's where we subtract the powers. So 3 minus 28, that's negative 25 over 12. And we know that that guy is not happy at all, so we're going to put him to the bottom to make him happy. So it's 1 over x raised to the 25 over 12. That's your best answer for full points. Totally simplified, we say. Okay, everybody gets a 3 as a power. So 3 to the 3rd, x, negative 4 times 3, that's negative 12. Negative 2 times 3, that's negative 6. We're going to just simplify it a little bit. So 3 to the 3rd power is 3 times 3 times 3, so that gives you 27. And then these guys raised to the negative exponent are just not happy at all, so they need to go down to the bottom. So that would be x to the 12th, and then y raised to the 6th. All right, we're just changing this to a radical form. So the 3 on the bottom, that's your index. This is called an index. So 3rd root of 27x, okay, that's just changing it to radical form. Then it says simplify the numerical expressions whenever possible. So we know the cube root of 27 is actually 3, and then we're still going to leave the x under that radical, so there's your best answer. Okay, rewrite in radical form again. So the denominator, that's your index. So we got 5 on the outside. Then we're going to have x squared because of this part, and then we're raising it to the second power. So x squared squared. So that's not terrible. It's not a terrible answer. It's just we could do x squared squared. We could multiply those together. 2 times 2, so 4. That's a little better. All right, we'll change this to a radical. So the 4, that's your index. So that's the 4th root of 7x. Done. Can't really do the 4th root of 7. It's not a perfect 4th or anything. All right, we're going to change this one. Now we're going the other direction. We're going to change it to exponential form. So we're going to say we've got 3 raised to the 12 over 6. Remember how the index is the denominator. Then we have x raised to the 5 over 6. 3 raised to the 12 over 6 is really 3 squared. X raised to the 5 over 6. And we know 3 squared is just 9, so 9x raised to the 5 over 6 is the most simplified, cleanest. All right, this one we're going to combine them, but we have to make them both at least the same. So we'll make them both fractional exponents. So right now this is x to the 1st. So let's make it x to the 1/7. Again, the index is the denominator. We have x to the 1/2. So we're going to go for a common denominator. It's a 7 and a 2 on the bottom. So let's go for 14 for both of them. So 14. All right, so the 1/7, we're going to have to multiply this top and bottom by 2. So that's going to be 2 over 14. That's the same. Then we're going to multiply this one by 7. So that's going to give us 7 over 14. That's the same as a half. And we're going to be able to keep the base, and we're going to add the exponents. So we have 9 over 14. Same directions. We're going to change this one. Remember, if there's not a number there, we know that it's a square root symbol. So the index is 2. So we have x raised to the 4/3. We have x raised to the 7/2. We're going to need to get a common denominator. So we see a 3 and a 2 on the bottom. Let's go for a 6. So we'll put 6 on the bottom of each. So this one, to get the 3 to be a 6, you got to multiply by 2, top and bottom. So let's make it 8/6. And then to make this one a 6, you got to multiply by 3. So let's do 3 top and bottom. So that would make this 21. Now we're able to work with this a little bit. So we can keep the base, which is the x, and then add those exponents. So we got 29 over 6. That's your best. All right, we're going to solve this radical equation. It is a radical equation. This is raised to the 1/2 power, which is the square root of x plus 5. I don't always, make it a radical. You definitely can make it a radical x plus 5 first and go this route. I don't normally do that, but you can. And then you can square both sides. And then it gets rid of the radical because they undo each other. And so then that leaves you with x plus 5 on the left. And then on the right, that's 225. Then we're going to subtract 5. And we get x equals 220. Always got to check your answers, so make sure you throw it in there. I'm going to save a tiny bit of time and not check every single one, but because I'm going to do a little mental math. This is 220 plus 5, that's 225. That's the square root of 225, which is 15, so check. It does work. Of course, I have it on the next slide, too. That's what I'll do. I'll just check the slide on the next one for checking. All right, so this one, you always want to make sure you isolate the radical. I know you're not really looking at a radical there, but the 1/3 power is a radical. So we're going to divide by 4 first. So then that's 3x plus 4 raised to the 1/3. Negative 20 divided by 4, that's negative 5. Now to get rid of this 1/3 power, you can just raise it to the 3rd power. Because it's really nice, they'll just cancel out like that. So then it'll just be 3x plus 4 raised to the 1st power, which is, you don't write anything. So you just write 3x plus 4, and then negative 5 times negative 5 times negative 5, which is negative 125. And then you solve for x, so you subtract 4 from each side, and we get 3x equals negative 129. And then you can divide by 3, and I didn't realize that was negative 43, did do earlier. So, and then I did check that one, and it does work. So good, we can circle it with confidence. All right, this one, we're going to do the same thing. We're going to get rid of the radical by squaring both sides. Okay. So on the left, it's x minus 3, and then on the right, you can do x minus 5 times x minus 5, and you have to multiply this out, so, I don't know how much work you need on this, but it's going to be x squared. I usually do the outside, that's minus 5x, and then the inside, that's minus 5x. So when you add those two together, you get minus 10x. And then negative 5 times negative 5 is plus 25. X minus 3. You have to slide everything to one side, so you have to subtract x, and you're going to have to add 3 to move it all over. So let's do that. So we're going to minus x, and we're going to add 3 to the appropriate terms here. So we have x squared, we got minus 11x, we got plus 28. Then we're going to do a little double bubble. We're looking for two numbers that multiply to be 28 and add up to be negative 11. With a little bit of work, we come up with 7 and 4. Minus, minus, both. That means if you take the x minus 7 and you set it equal to 0, you're going to get x equals 7. And then you're going to set the x minus 4 equal to 0. And you get x equals 4. And then you should check them both. And there's my checking off to the side there. And I got the 7 working, but the 4 doesn't. All right, this one we're going to isolate the radical first. So we're going to subtract 2. That's going to give us radical 3x minus 1 equals negative 1. Then we're going to square both sides. So that gives us 3x minus 1. We got rid of the radical. Negative 1 squared is negative 1 times negative 1, which is a positive 1. I know if you plug that into your calculator, you're going to do negative 1, and you're going to do squared, and then your calculator is going to say, hey, the answer is negative 1. Well, that's because your calculator is really smart in some ways because it knows the order of operations. So if you do this, it knows that it's supposed to do the 1 squared and then attach the negative sign. So if we want it to be correct, we want to make sure we put negative 1 in parentheses and then we square it. And then, of course, it's what we know it should be. It's supposed to be a positive 1. Okay, then we're going to add 1 to each side. It's 3x equals 2, so x equals 2/3. Now when you plug this one in, it doesn't really work. So it kind of looks like this. It's square root 3, if you put the 2/3 right there, minus 1 plus 2 equals 1. What happens here is the 3's could cancel out, and then that's 2 minus 1 under the radical, which is really just the square root of 1 plus 2. So that's 1 plus 2 equals 1. Nope, does not work. That's 3 equals 1, which is not true. So no good on this. This has no solution. All right, this one we're gonna square both sides. We've already got the radical isolated. So square both sides, we get rid of the radical. On the right-hand side, you need to write this out. X plus 1 times x plus 1. I'm going to multiply it out. I get x squared plus 2x plus 1. That's what I got. Then I'm going to subtract the x. So that would give me plus x. I know I'm showing less work. Minus 7. So what's 1 minus 7? That's minus 6. And then we're going to do a little double bubble. Let's go plus 3 and minus 2. So then our two answers are x equals -3 and x equals positive 2. We need to check these out. So let's look on the next slide and see which ones worked here. Looks like the 2 worked. The -3, no good. And is that it? Woo! Woo! All right. Good luck. You can do it. Oh, can I spell luck? Good luck. All right. I hope you do awesome. All right, later, Skitter.